let's look at this example. I just want to solve a few more problems here. So this is example number 22.4. Let's try to have it. So again, now, so again, try to read this problem. Now, each time that you solve a problem, the very first thing is that you want to ask yourself, what is the, so what is this problem talking about? What is the principle? What am I trying to really look at in this problem, right? So the very first thing that you do is to try to identify, do you understand what the problem is talking about? That's the very first thing, right? So in this problem, we have two identical, notice that each of them is positive. So this is a positive charge and this is also a positive charge. And then it tells me that each of them have a mass of 3.0 kilograms, 3.0 times 10 to the negative 2. Then it hangs in equilibrium. It gives me the length of the string, and it tells me what that angle is. And then it says, find the magnitude of the charge on each of these spheres. So when we solve this type of problems, so what are we trying to calculate here? We need to calculate Q, right? So we need, so Q is what we're trying to calculate, right? Then I need to look at this keyword here. So when we say something is in equilibrium, what does that mean? Net charge can be zero. But what does that mean in terms of the forces acting on the system? Zero. The forces must balance, right? So all the forces must balance. So the sum of all the forces must be equal to 0. And then the next thing is to ask myself, what forces am I talking about in this problem here? So we need to go ahead and identify all the forces acting on the system. So first, so for example, maybe we can put a force of tension here, a force of tension right there. And then there's some force of gravity pointing down, right? And then there is an electric force pointing like that. When I calculate the electric force here, notice that it's pointing to the right because this is positive, right? So if you have two positive charges, you get a repulsive force. Now, what is this angle here? If this angle is theta, this angle should also be equal to theta. And so you can see that I can take this tension force, I can take my force of tension and I break it into X and Y. So let's see if they have a solution. So this is what I'm talking about here. Now, let me go ahead on share, so just I can explain this a little bit more. So this is the problem that we're talking about here. So we have, so this is positive charge. And this is positive charge. Then it tells me that the distance from here to here is A, and the length of this string is L, and this angle here is theta. So when I look at all the forces acting on the system, there is a force of tension here, there is a force of tension here, there is a force of gravity here, which is M times G. There is a force of gravity here, which is M times G. There's an electric force here, which I'm going to write Fe. There's an electric force there, Fe. Now, so just if you focus on, so just focus on one sphere. So pick one sphere and look at all the forces acting on this. So we have M times G. Look at this electric force. Now let me say that if you take this force of tension here, you can break it into, so this is theta, so this would be T cosine of theta like that. This would be T sine of theta. So then there's a force here, T sine of theta. There's a force here, which is T sine of theta. So we want all these forces to be balanced. If all these forces are balanced, it means that, so I can write two equations here. So it means T cosine of theta must be equals to M times G. T sine of theta is equals to F electric. Now, if the distance from here to here is A, the distance from here to here is also A, then I can calculate my F electric as KE. Now, Q1 is equals to Q2, so Q squared. That distance is 2A, so 2A squared is 4A squared. So that's the electric force. So now we have these two equations here. So this is my two equations that I want to solve. Remember that what I need to calculate is my charge Q. So what I can do is that I can divide those equations to get tangent of theta is equals to F electric over mg. So from here, so from this equation, I can calculate my F electric mg tangent of theta. Then once I know this F electric, I set it equals to this value here, then solve to get Q. Again, let me take that again. So what I want you to see is the flow of the problem, right? So the first thing is to identify the forces acting on the system. A force is a vector quantity, so you want to write all the forces in terms of the X and the Y, right? Then once you have all your forces in the X and Y directions, we're going to say that, so this force must be equals to this force, and this force must be equals to this force. You solve that equation, you can get your F electric. Once you know that, again, you can use this equation to get what the charge is. Is there any questions on how I set this up?
Why is it 4a squared instead of just a squared?
It's 4a squared because the distance between these two charges is 2a.
Okay.
And remember that when I calculate force, it's Q1, Q2 over distance squared. So if you square 2a, you get 4a squared. So the very first thing, again, when I'm solving a problem, I don't need to look at my calculator first, right? I need to solve, because once I understand, I can always go back and plug in the numbers, right? So for example, if you look at this problem very well, it tells me what the mass is, I know what gravity is, it tells me what the angle. So I can always calculate things on my calculator, but the first thing that I want to do is to understand the principle. So what is the physics behind the problem? So once we solve and we get this electric force, then you use this equation here, we can solve for Q. Right? So let me go back and let's see what we get as the final. So let's open. So if you plug in everything here, now if you see this is the same equation that I was talking about, and this equation right there. All right, then you can do a little bit of tricks here, but if you do everything, so it tells you again how you can calculate your A, and then if you just solve this equation here, you get this value, this charge. So again, so this picture really shows you, so this is called the force. So those are the forces. Those are the forces acting in the system. So at the end,